Alright, in this video we're going to practice graphing some reciprocal functions with some transformations. So we're going to look at f of x equals 1 plus 1 over x. And in class we mentioned that you see that plus 1 in the front there, that's going to cause a horizontal shift of up 1 unit. So from class we remembered that we had asymptotes y equals 1. So originally the reciprocal function had an asymptote at y equals 0. The adding 1 is going to shift everything up 1 unit. So we're going to have a horizontal asymptote at 1, and then we're going to have a vertical asymptote after we factor and reduce. There's nothing to reduce here. And where the denominator is equal to 0, and that's going to be x is 0. Okay, so we have those two asymptotes, and then what we're going to do is we're going to graph those asymptotes as dotted lines. So x equals 0 appears as this kind of red dotted line right over the y-axis. So here it is right here, and then we'll go ahead and graph in the horizontal asymptote y equals 1. Okay, and if we remember our reciprocal function did something along these lines, and what we're going to do is we know that basic shape, and it looks like it's going to cross the x-axis somewhere around here, and we would like to find those intercepts. It's not going to cross the y-axis, because if we're crossing the y-axis, x is 0, but we can't divide by 0 because that's no good. Okay, so what we're going to do is we're going to find the x-intercept. So when we're crossing the x-axis, the y is going to be 0. So that's what's going on here. So the intercepts, no y-intercept, and we just mentioned because if we're crossing the y-axis, the x is 0, but x can't be 0 because we'd end up dividing by 0. So we don't have a y-intercept, but we do have an x-intercept, and that's when the y is 0. Okay, so we're going to remember f of x is the same thing as y, so we're going to replace the f of x with the 0, and we're going to solve the equation for x. So I got an x in the denominator, so we're going to fraction bust, and we're going to multiply everybody by x. So multiply everybody by x. Okay. On the left-hand side, x times 0 will be 0. 1 times x will be x. And then 1 over x times x will just be positive 1. And if we solve that for x, we would subtract 1 from both sides, and we'd get x is equal to negative 1. So we're going to have a y, not a y, we're going to have an x-intercept right here. So I know I'm going to cross right there. I know that it approaches its asymptote, so it gets like way close to the asymptotes. So I know that behavior. So I know I'm crossing the x-axis here, and I'm going to approach my asymptote. So that's how I know that. We also graph the parent function, which is this is just a transformation of it. We just shifted it up 1. Okay. And then on the other side is kind of the same shape. It's going to approach its asymptote. And then we'll mention that the plus 1 there is just going to be a shift up 1 unit. Okay. Let's look at another one. G of x is equal to 1 over x minus 3 squared. And this is a little bit different. It's not quite a transformation, because transformations are stretches, squeezes, shifts, but this one's going to be a little bit different. It's going to have an asymptote where the denominator is equal to 0. It's already factored, so x minus 3 is equal to 0 when x is going to be 3. And then if I FOIL out that denominator, I would have an x squared. And to look for the horizontal asymptote, the top is just 1, the bottom is an x squared. So the 1 has a exponent of 0. So the denominator is bigger, and that would tell us that we have a y-intercept, or not y-intercept, a horizontal asymptote at y equals 0. And so that's this horizontal line right here. And then we're going to have a vertical asymptote of 3. So somewhere along there, we're going to draw in a dotted line for that asymptote. Okay. The other thing I want to look for is to help with the graphing is I would like to know if I have any x or y intercepts. So if I'm looking for the y-intercept, that means we're on the y-axis, and the x is going to be 0. So we're going to replace x with 0. So we have f of 0 is 1 over 0 minus 3 squared. So all we did is we replaced the x with a 0. So that's going to be 1 over 0 minus 3. Okay, and then when I square the denominator, that's going to be 9. So we're going to have 1/9. And I'm going to have a y-intercept 0, 1 over 9. And I'm going to do the best I can to approximate it. The graph's not super accurate here, but I'm going to make it yellow, and we're going to pretend that's 1/9. It's close enough. If you have graph paper, you could do a little bit better job than what I'm doing here. Now, I know I'm going to be approaching my asymptotes. I might be doing this variety, but I'm not going to do that variety because I know I'm going to cross the y-axis up here. I'm not crossing it down here, so I know I'm not going to be down here, down below. So I'm not going to be down below, but I could be down below here. And it turns out that I'm not going to be down there below. And the reason why is this thing right here, 1 over x minus 3 squared, 1's positive, and the denominator is always going to be positive. So it's always going to be positive. If I got stuff down here, that's going to be negative. So I'm not going to have any negatives. So if I'm not going to have any negatives, I'm going to have something like this, where I'm approaching the asymptote from both sides above my my horizontal asymptote. I'm going to go ahead and mention that we don't have an X-intercept because usually I don't cross my horizontal asymptotes. There are some times when I might. And the reason why I don't have an X-intercept is I'd have zeros equal to 1 over that x minus 3, that stuff right here. When a fraction's equal to 0 is when the numerator is equal to 0. But the numerator is 1, and 1's never going to equal 0, so I don't have an X-intercept here. Okay, so it's just as we said before. We're gonna look something like this. Both branches are going to be above, and they're going to approach that vertical asymptote, and they're going to flatten out as I get further away from the y-axis. That's the end behavior. Okay, so we'll go ahead and graph that in, and that's it. There's your graph. Not super accurate, but we're looking for a rough sketch. We want to know where the intercepts are and where the asymptotes are, and then that'll give us kind of a general shape of it. Okay, let's do one more. H of x is going to be equal to 1 plus 2 over x plus 5. This is a transformation of the reciprocal function. The 1 here is going to shift us up. The 5 here is going to shift us to the right 5 units. So the original horizontal asymptote was y equals 0, and if we're shifting up, it's going to become y equals 1. The original reciprocal function has a vertical asymptote at x equals 0, and because we're shifting it to the left 5 units, we're now going to have a vertical asymptote at -5, and that's where x plus 5 is equal to 0 also. It's already factored and reduced. There's nothing to do there. The 2 in the numerator is just going to stretch it, which might be a little bit hard to convey, but it means the function's going to grow a bit faster. Let's go put it in our x and y axis, and then we'll mention that the 1 is up and that 5 means a left 5. Okay, and then we'll go ahead and mention those asymptotes. Y equals 1 and x equals -5. So we'll go ahead and graph them. Y equals 1 is a horizontal line. X equals -5 is a vertical line. And the shape we had before, this is just a transformation. So it's going to look like this. It's going to fit within its asymptotes here. But you see that I'm probably going to cross the x-axis there, and I'm probably going to have cross the y-axis here. So x-axis here, y-axis here, I'm going to cross. I kind of want to know what those are so I get a little bit more accurate of a graph. So we'll go ahead and find I think we find the y-intercept first, and that's when x is 0. So h of 0, we just plug 0 in. Okay. So it'll be 1 plus 2 over 0 plus 5. That'll be 1 plus 2/5, and if you want to use your calculator, that's 1.4. Or you could leave it as a mixed number, 1 and 2/5. The reason why we don't really like improper fractions is it's a bit harder to graph improper fractions, so it's better to put it in a decimal or mixed number. So our y-intercept is about almost 1.5. So it's right here. That's where we're crossing the y-axis. And then we'll go ahead and find the x-intercept. And usually the x-intercepts tend to be a bit trickier in terms of in terms of solving for it. The x-intercepts when the y is equal to 0. And remember, h of x is y. So 0 is equal to 1 plus 2 over x plus 5. And kind of like the first one, we're going to have to do a little bit of fraction busting. The LCM here is just x plus 5. So we're going to multiply everybody by x plus 5 to get rid of the fraction. Okay. On the left-hand side, 0 times x plus 5 is just going to be 0. 1 times x plus 5 is just going to be x plus 5. And then on the last term, the x plus 5s are going to cancel, and we're just going to be left with 2. Okay. If I solve that, adding the 5 and the 7 adding the 5 and the 2 together will give me 7, and then I'll subtract 7 from both sides, and then we'll get x is negative 7. So that means we're going to cross the x-axis at negative 7. Okay. And I know I'm going to flatten out to my asymptote, and I know I'm going to cross my x-intercept at negative 7, and then I'm going to flatten out to my asymptote. Over above, we're going to flatten out to our asymptote, and we're going to cross our y-intercept and flatten out to our other asymptote. All right, and we'll go ahead and graph this. And it's just combining a couple of skills that we've been developing. Probably the hardest part is finding the x-intercept, just because the algebra is maybe a little bit tricky. But the shape's usually going to be pretty similar.